Okay, so let us now discuss remainder theorem. So after you have learn about synthetic division and long division or finding for the quotient of polynomials. Let us now go to the remainder theorem. Now, in using synthetic division or long division, there are possibilities that the divisor is not a factor of our polynomial. Thus, if the divisor is not a factor of a polynomial, it will give us a remainder. So thus, we have this topic, remainder theorem, because we're not going to use long division anymore or synthetic division in finding for a possible remainder of our polynomials. So here, by definition, if a polynomial p of x is divided by x minus a, then the remainder is r is equals to p of a. So let us solve number 1. Find the remainder when x cubed plus 2x squared minus 5x plus 2 is divided by x plus 3. So, with respect to our definition here, that p of x, this is our polynomial when divided by x minus a, and this is our divisor, the remainder will be p of a. So here, x is replaced with the value of a, and that is whatever the value after we solve x plus 3 is equals to 0. So this becomes p of x is equals to x cubed plus 2x squared minus 5x plus 2. Now, our x plus 3 is we're going to express our divisor into we're going to equate that with 0. So this is x plus 3 is equals to 0. So thus, the value of x transposing 3 on the other side will be negative 3. So therefore, the value of our x is negative 3. That our negative 3 is substituted on our x's, then we simplify. So therefore, this becomes our p of negative 3, then this becomes negative 3 cubed plus two times negative 3 squared minus 5 times negative 3 plus 2. Thank you, ma'am. Then we simplify our negative 3 raised to 3. Now, what is negative 3? What is negative 3 raised to 3? So that means that the number or the base negative 3 is multiplied 3 times by itself. So this negative 3 times negative 3 times negative 3 is negative 27. Then plus 2, we simplify first this one, negative 3 times negative 3 is positive 9. This is negative 5 times positive 3 is negative 3 is positive 15. Then we copy 2. Then we try to simplify first this one, so that after simplifying, we will only have addition and subtraction. So this is negative 27, 2 times 9 is positive 18, plus 15, plus 2. Now, we can solve this left to right, or we can combine this one, and then we subtract with our negative. We copy negative 27, so I'm going to combine all the positive, then after we subtract it with 27. So this is 18 plus 15, so that is what? 30. 3 plus 2 is 35. So negative 27 plus 35, negative 27 plus 35, integers is subtract the numbers and copy the sign of the bigger number. So that is positive 8. So therefore, our p of negative 3 is equals to 8. So therefore, it means that if this polynomial is divided by x plus 3, the remainder is 8. So that is by using our remainder theorem. Let us try to compare this one in using our synthetic division if we can get still negative 3 as our remainder. So we copy the coefficients 1, 2, negative 5, and 2. By using synthetic division, x plus 3, still our divisor is negative 3. Then we simplify, we copy 1, we multiply negative 3, this is negative 1, then multiply, this is 4, then this is negative 1, then, okay, again, 1, 2, negative 5, 2, and this is negative 3. 1, multiply negative 3, this is negative 1, we multiply is, sorry, this is not, rather this is positive 3, and this is negative 2, then we multiply is positive 6, then we simplify this one, that is 8. So therefore, the remainder is 8, and we have the same answer that the remainder is 8. So let us proceed to our second example. Okay, for our second example is, the problem here is, we're going to determine whether or not that x plus 2 is a factor of x cubed minus 2x squared minus 5x plus 6. So since we're going to identify or determine whether x plus 2 is a factor of this one, what we're going to do is we're going to use the remainder theorem. So then this becomes our p of x is equals to our polynomial x cubed minus 2x squared minus 5x plus 6. Then our x plus 2 is equals to 0. So therefore, x is equals to negative 2. Now we replace all the x's with our equation to negative 2. So therefore, this becomes p of negative 2 is equals to negative 2 cubed minus 2 times negative 2 squared minus 5 times negative 2 plus 6. Then we simplify. So this is our p of negative 2. Negative 2 times negative 2 times negative 2 is negative 8 minus 2. Negative 2 squared is positive 4. Negative 5 times negative 2 is positive 10 plus 6. So our p of negative 2 now is we simplify. First, this one is negative 8. This is negative 8 plus 10 plus 6. So then we simplify. Negative 8 plus negative 8 is negative 16 plus 10 plus 6 is 16. So what is negative 16 plus 16? So therefore, our p of negative 2 is 0. So if we get 0 here, it means that our x plus 2 is a factor of our p of x, x cubed minus 2x squared minus 5x plus 6. Since our final answer there, or after we simplify or after we substitute that our x minus a or our x is equals to negative 2 is 0. So that is how we're going to identify if the given divisor or a given polynomial or a given binomial is a factor of our p of x. Okay, now for our example number 3, find k so that x plus 5 is a factor of our p of x is equals to x cubed plus 5x squared minus kx minus 20. So the problem here is we have an unknown value here, the value of k. But the problem states that our x plus 5 is a factor of this one after we have solved for the value of k. Okay? So therefore, if this is a factor of this one, it does not have a remainder. Okay? It does not have a remainder. So therefore, in order for us to solve for this one, this becomes p of x is equals to x cubed plus 5x squared minus kx minus 20. So then again, our p of negative 5 is a factor. So if we simplify or if we substitute our p of negative 5 here, it will be equal to 0. So let us now simplify or substitute our negative 5, our x, after we have solved x plus 5 is equals to 0. Therefore, x is equals to negative 5. So let us simplify now. Let us exchange all the x's with our negative 5. This is negative 5 cubed plus 5 times negative 5 squared minus k times negative 5 minus 20. Then we simplify now. Remember that our p of negative 5 is a factor. So therefore, this is 0 here. Then we simplify this one. Negative 5 times negative 5 times negative 5 is negative 125. Then we simplify this one plus 5 times negative 5 times negative 5 is positive 25 minus, so this negative k times negative 5 is positive 5k. Then we copy negative 20. Then we simplify this one. So this becomes negative 125 plus 5 times 25 is 125 plus 5k minus 20. So negative 125 plus 125 is equals to 0. So therefore this is now 0. So this will be 0. What is left for us is 5k minus 20. So if we have 5k minus 20, since we are going to solve for k, we transpose negative 20 on the other side. Transposing that one will yield to positive 20 is equals to 5k. Then solve for the value of k, divide this by the coefficient 5. So therefore, k is equals to 20 over 5 is equals to 4. So therefore, the value of k is 4, so that our x plus 5 is a factor of our p of x. So that is our remainder theorem, and the next lesson will be the factor theorem. So if you have questions, you can message me, or you can comment your questions on the comment box below. Please like, share, and subscribe to our channel, and share these videos to others also. Thank you.